Okay, I was looking at the testing schedule, and it appears that your next test comes on Wednesday. All right, so we have a few days left where we're going to teach you some new stuff, and then we have another test. Tests come along about once a week or so. So just kind of be expecting that. All right, we're going to review domain. We're going to be talking about the basics of polynomials. We're going to talk about increasing and decreasing again, what you did yesterday. Mins and max. It's just I do a lot of review, and hopefully that'll be good for those of you that weren't here yesterday. Although you should have watched the video. Here's the big thing, though. Odd versus even functions. All right? So, take a look at this one. By now, you should know that this has both of the problems we're looking for. It has a square root, which you take and set greater than or equal to 0. And it has a denominator, which you set equal to 0. And you find them, you put them on a number line, and then you get your answer. Go for it. Do it right now. When you're all done, you should have a number line that says, the domain of this is everything works except this and this, or it works between here and here. All right, hopefully you knew enough to take this and set it greater than or equal to 0. X greater than or equal to 0. And there's nothing really to solve. It's just that. So then I put it on my graph and say 0 is kind of important. And does it work at 0? Yes, it's okay to be 0. It just can't be a 0 in the denominator. All right, so then it's bigger than 0, which generally means we go this way. Now the other number, though, is 2. So I really probably shouldn't shade that yet till I look at my other number, because that might like mess it up a little bit. X has got to be 2 to make the bottom 0. If x minus 2 is supposed to be 0, x equals 2 will be the thing that crashes. So x cannot be 2. So here's 2, empty spot. Then, see why I needed to unshade that area? Because it's bigger than 0, but not 2. So I'm guessing this is it. Now, how can I be sure? Check. Test regions. So I'm going to test between 0 and 2. I'd test 1. If I stick in a 1, does that cause a problem? Notice we don't care if the answer is right. We just care, did it crash? Does the 1 crash the top? Does the 1 crash the bottom? No. So the 1's good. Check 3. Does 3 crash the top? Does 3 crash the bottom? No, because it would only be crashed if it was 0 down there. And so that worked. Yay. And let's just double check this area like -1. As soon as I put it in, I see the problem right away, right? Square root of a negative can't work. So clearly that's out. Final answer should be between 0 and 2. And then a bracket on the 0 and a parenthesis on the 2. Union with 2 to infinity. Raise your hand if you had that one right. Awesome. Okay, so that's domain. That was a simple one, but it would be the same concept if it was something complicated under here. You just set it greater than or equal to 0. And if it was something complicated here, you just set it equal to 0. All right. So now let's talk about local mins and maxes. This spot right here, what's that? Local min. How about that spot? Local minimum. It is a local minimum, and even if it's the lowest spot of all, like that one, it's still a local low spot, but it's also the lowest spot of them all. So it's a local minimum and an absolute minimum. Yes? Yes, that'd have been okay. Oh, wait. If you try to do this with all reals, you're going to have to say all reals where x is between 0 and 2. Okay, so that would be complicated. You could do it, but I would do this way. Whenever there's shaded in areas, use that other way when it's like 2 doesn't work, 5 doesn't work, and everything else does. You know what I mean? If everything else works, then it's a good way to say all reals where x is not 2 and x is not 5. But as soon as like this whole area didn't work, then it's more complicated. You'd have to say x cannot be less than or equal to 2, and then that's a sign we pretty much almost never use. But it actually would be okay. All right, back to this. Those are local minimums. What are these guys? Local maximums. All right, and then talking about where it increases and decreases, would you agree if this spot right here looks like it's at about 2 comma -2? Look at it close and see, does that seem about right? Looking at the numbers here, see it's right up from 2. And then that spot right there is definitely below 0, isn't it? Or is it more like 2 comma -3? Or what do you think? 2, okay, I'll leave it that way. And this spot here looks to be about 3.1 comma, and it's above, is it like 6 or 7? What do you think? How high above 5 is it? Okay, I'll go 6. All right. So now this little zone right here is increasing, but the problem is a lot of kids are going to use the wrong numbers. Try writing that for me. Just that one little zone. Make sure you use the right numbers. It's increasing between what and what? Grab your pencil and just sit there and stare at it. It's okay to think for a second, but then write. Football player in the back corner that I can't say your name because we're on video. What is your numbers you chose? Increasing from 2 to 3.1. You chose the x values, and you were correct. 2 to 3.1. Could you use brackets or parentheses? Yes, I'm okay with both. I think parentheses make the most sense because I think when it hits 3.1, it's done increasing, and it's not increasing at that point. So I use parentheses. But you could argue that brackets would be okay, too. I've seen some books do that. All right, how about this one? Where's that increasing from? About what to about what? Would you agree it's about 4.5? Remember, it's the x that matters here. Okay, so it's about 4.5 to infinity. Does that make sense for this part right here? Good. All right, that's the main thing you needed to know there. Oh, wait. And with lead coefficient we were talking about before. See how this end's going up? That means that my equation for it, y equals blah, 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 must have a positive in front of it because it's going up at the end. This says this is a positive number. Because if it was a negative number, then it would be going down at the end. Like you've seen those before, y equals negative x squared. It'll be upside down. It ends going down. The right-hand side is what this is telling you. We're going to use that a lot more later, but for right now, I just want to remind you. All right, we did one like this yesterday. In fact, we did that exact one yesterday. I want to do another one with you. We'll just change this slightly. We'll go x minus 5 parentheses x plus 1 quantity squared. Would you graph that thing I just wrote and read there on your graphing calculator, and then tell me what the minimum spot is? You learned how to do this yesterday. It's under second, calculate minimum. I do have a few extra calculators. If you want to borrow one, there's one on top there, and then there's some down here. All right, so to start with, just type this puppy in. X minus 5, x plus 1. They're both in parentheses. Okay, I'm back, and we have it graphed here. If I hit graph, and I should be able to see the little loop-de-doo. Oh, I can't see the low spot, and that means I can't use my calculator to find it if it's not on the screen. So I need to zoom out. I can go zoom out is number 3, and I have to hit enter twice to get it to zoom out. All right, now I feel like I zoomed too far out. So I'm going to do the zoom box. Zoom box. I encourage you to get used to this one. The zoom box is pretty slick. Zoom box, it's the top one. And then it brings up the little plus sign, and it's blinking usually right in the middle there. That's that white spot you can barely see. And then you make a little box, hit enter to start the corner, and then you make a little box around the area that's important. Make sure you go low enough so you can see that low spot. And that looks pretty good. I'm going to hit enter. Now I can definitely see the low spot. Really nice. Okay. Everybody got it so you can see the low spot? Anyone? Bueller? Okay. All right. Good. Oh, you actually found the low spot. Hold on just a second. I'm not ready yet. I just want to make sure people have had it on their screens. I go second, calculate. And the low spot's the minimum. That's number 3. Second, calculate minimum. Now we got to go to the left of the low spot. Now I am to the left of it. I want to get a little closer, but I don't really have to. And then notice it put a little triangle on your screen. It says from here to, and then you arrow over past it, so you're on the right of the low spot. From there to there. See those two little guys right here and here? They're telling you, they're going to give you the low spot between there and there. And then you just go back a little closer to it and then say enter. And it says x is 3 and y is negative 32. Raise your hand if you got the same thing. All right. 2.99999999 is pretty much 3, isn't it? I know it. I know you feel like it should be exact. Look at mine. Mine isn't even exactly 3. Mine's 3.00000015. See, yes, you can round those. All right. Why the calculator isn't exact on that, I really love to find one of the TI guys that designed this thing and ask them why they did it that way. Why can't they just use the function to do it? But I think it's something about how it's just reading its own graph. And it can't read its own graph super accurately. That's all I can figure. All right, so now, why would you ever do that? Because now if I asked you to tell me where does it start increasing, you could say, well, it starts increasing at negative infinity until you hit 1. That was this spot right here. Oh, sorry, that's not 1, that's negative 1. Negative 1 comma 0. Remember, it's the x numbers we use on this. From negative infinity to negative 1, and then it starts increasing again right there. And how do I know where that is? By using this little technique I just showed you. You know it's there to there. So it's 3 to infinity is my other increasing interval. Okay, those are the increasing ones. How about the decreasing? It's decreasing from what to what? Yep, negative 1 to 3. There to there. Negative 1 to 3. All right, so that's increasing and decreasing and finding the minimum spot. The maximum spot you could do pretty easy, just the same way. You'd find out it was at negative 1 comma 0. You'd have to round the numbers a smidge to do it. All right, so now let's move on to this. For this next part, you need to remember some stuff. I'm going back to algebra, and actually probably higher algebra. Remember when you had a function like this, and then you stick in a number like f of 3? You just stick the 3 in for the x. This is the spot where you normally put x, right? So f of x and f of 3. So they're saying, I want you to put this wherever x is. So then you put it in, and the x is right there. You drop in the 3 right there. 2 times 3 minus 4. And that'd be 6 minus 4, and that'd be 2. Raise your hand if that's easy. Okay, good. Then, what is f of negative x? That's a little weirder. All it is you start with your function, and I strongly recommend you do this. Put an empty spot like that. That's my function. It's an empty spot where the x was. And then just whatever they tell you, drop that in. If they told me 3, you drop a 3 in there. They're telling me negative x. So just drop in a negative x right there. Now let's multiply that out. What's 2 times negative x? Negative 2x minus 4. There's my answer. To see if you're really getting that, oh, actually I'm going to show you the last kind. This just means when there's a negative on the outside, that just means opposite of. Okay, if I said, here's 5, and then I throw a negative on the outside, I mean opposite of 5. Did you get what I mean by that? All right. If I had x plus 1, and I stick a negative on the outside of all of it, then I want the opposite of all of it, which would mean the opposite of the x is negative x, and the opposite of the 1 is a negative 1. Okay, so that would be a negative x minus 1. All right, so now, here's the thing. If I ask for negative f of x, I just want the normal f of x function, which what is f of x? It says so right here, 2x minus 4. So I just take 2x minus 4. And what do you think the most common mistake is that kids make? They're going to put in a negative, right? And so what do you think they do? Yes, they just stick the negative right there. You get how that's wrong? We want the opposite of everything. So this is my function. I'm going to want the opposite of everything. So opposite of the 2x and the opposite of negative 4, just plus 4. There's my final answer. All right, I want you to try one of those. So there's one. Give it a shot. First, just figure out what f of negative 2 is. That's one answer. This is a completely different question. Then figure out what f of negative x is. And then figure out the opposite of function. Just take the normal function and throw a negative on the outside. Just make sure you do the negative of everything. We're setting you up to be able to do a test that tells you whether something is odd or even. And this is like the background knowledge, stuff you got to know before you can handle the next part. All right, hopefully f of negative 2 is pretty easy. Just take your function, write an empty spot cube plus 1. I'm curious how many of you used my empty spot technique. Be honest. Okay, you're going to want to do that when it gets to the hard ones. Empty spot, drop in negative 2. Okay? And then you go negative 2 cubed is negative 8 plus 1, which makes negative 7. Raise your hand if you've got negative 7. Okay, good. Next kind. You put an empty spot where the x is. Okay? It's just the same exact thing as I had before. Just write it with an empty spot. And I'm going to drop in negative x. What happens with negative x cubed? Does that stay negative, or does that negative go away? Stays negative. Final answer is negative x cubed plus 1. That's kind of annoying. Okay. So, the last one. Oh, by the way, is there anything else to do here? No, that's it. The only hard part was I dropped in a negative x, and I see what happens to the negative. Sometimes if it had been squared, for instance, the negative would turn positive. But in this case, since it's negative times negative times negative, it's still going to be negative. All right. And then the last one is this one. It's just the easiest one. It's just opposite of whatever the normal function is. So you write the normal function, x cubed plus 1. And then you just do opposite of it. Throw a negative in front, but don't forget to do the negative of both. So it's negative x cubed minus 1. Get that? Yes. How come we left the cube sign on it? Because I am still cubing it. I am still timesing it by itself 3 times. All I did here was, think of this as a negative 1 out in front. And I'm doing this times this. And then I'm doing this times this. Maybe you're thinking of, if I had had a cube here, I'd have to times it by itself 3 times. And that's not what I'm doing. Maybe I'm totally missing your point. Do you want to ask it again a different way, or did I answer it? Okay, good. All right, so one more. Let me see if I made one more. No, I didn't. I think I needed one more. Let's say I have f of x is 3x plus 1 over 2. What would f of 5 be? You can do it in your head. Got it? You get 8? I agree. 3 times empty spot plus 1 over 2, and I drop in a 5. 15 plus 1 is 16. 16 divided by 2 is 8. You get that? All right. The harder kind is where I say, what's f of negative x? It's not hard, but go ahead. Drop in a negative x. 3 empty spot plus 1 over 2. Negative x goes in there, and I get negative 3x plus 1 over 2. That's it. Raise your hand if that's what you thought. Okay, good. And the last one's just opposite of f of x. So that's just the opposite of whatever it was. So if I throw in a negative like that, then you just take the function like it was, and then throw the negative, and don't just slap it on the first number you see. But I put the negative on everything, like that. Now, it's important to remember, though, you're not going to put the negative on this and this and this. Otherwise, do you get how the negatives would all cancel each other again? Okay, so you only put it on the top, because technically what's happening here is you have a negative 1 here you're multiplying by, and that's negative 1 over positive 1. You know what I'm saying? And so the bottom is 1 times 2 is positive 2. All right, so when we do this, put the negative on the top. This negative would only distribute to that and that. So my final answer would be negative 3x minus 1 over 2. Yep. All right. So now, how do you tell a function is odd or even? Wouldn't it be awesome if it was as simple as, oh, they got an even number here. It's an even function. Okay, it's not that simple. It is related to it, but it's not that simple. Because otherwise you wouldn't, it wouldn't be pre-calc. It'd be like something you'd learn in 7th grade. So x squared is an even function, but it's not just because it has a squared there. And x cubed is an odd function, but it's not just because there's a 3 there, because it won't just follow that simple a rule. Okay, so how do we tell whether a function is odd or even? So if I give you this function like x cubed plus 3x plus 5, is that odd or even? I'm going to show you how we tell whether that's an odd function. It's not just, oh, look, there's a 3 there. It's an odd function. That does not work. Okay, there's a way to tell if something's an odd function. One way is to look. Do you see that odd functions have symmetry? This is an odd function. Do you see there's symmetry there? Like the left side of the graph and the right side of the graph are related. It's not as simple as symmetry like it's a butterfly wing. It's exactly the same thing over here. It's not that kind of symmetry. Well, that'd be a pretty hideous butterfly. But anyway, it's a special kind of symmetry called point symmetry. And it's saying that if you took this side here, every single point on it can be reflected straight through the origin, and it'll hit the other point that it reflects to. Okay, so here's a point. Do you agree that 2 comma 8 should be on that function? It makes sense. You stick in the 2, you get 2 cubed to be 8. Okay. Do you get that there's another point just like that on the other function? And if you were to draw an imaginary line, I'll use green here, that goes like straight through the origin and kept going like that, it'd eventually show you where to put it. See what I mean? So here it is. Here's the end result. There's another spot on here. 1, 1 is a spot on this graph. Over 1, up 1. See how that's rated? 1, 1. And again, if I use that same deal, I go straight through the origin, there'd be another spot right here. That's called point symmetry. You're learning a lot today. All right. But the hard part is not just looking at pictures. Pictures, you might be good at that quickly. Let me just show you another one. Odd symmetry or not? Yep. This point right here, it's going to be just like that point right there. See what I mean? This point up here, if I go through an imaginary line like this, there's going to be another point just like it down there. See what I mean? That's odd symmetry. Okay, even symmetry. Parabola. Yeah, it's simple symmetry. If I take and pick a point over here, there's a point just like it straight over there. Point over here, there's one just like it straight over there. It's just symmetry right across this line right there. Okay? Yes. Yes. And that's definitely important because you will have to be able to do this without a graph. But there's also questions that we ask you about graphs. So I'm trying to make sure I show you this way thoroughly. So if you see a function, I want you to be able to say, does that have odd symmetry or not? Yes, because it's going through the origin. This would match up with a point over there. It's perfect. Okay. How about, what kind of symmetry? Pretty bad, but it's supposed to have symmetry. What kind of symmetry would that be? Even symmetry. Okay, so that'd be an even function. All right. Next. Let's go back to that definition thing I'm going to read you. This is worthy of your notes. Put a star by it. You are going to have to do this on a test, and you will never just remember it. Huh? Okay, good timing. This is a really important thing to write down. You see why we were doing that stuff with f of negative x? and negative f of x. That's why I was practicing that before. Because that's how you can tell if something's odd, is if you've got the function and you do this to it, and you do this to it, and they come out exactly equal, then it's an odd function. I'll show you one. You'll get it after we do one. All right, so let's do the ultimate odd function. I've already told you it's odd. X cubed. That's an odd function. Y equals x cubed. So what I wrote down, or what you wrote down, was that if f of negative x gives me negative f of x, if this is true, if this is really equal, then this is an odd function. All right, you need one good example in your notes. Make this one of those. Okay, so write this one down. Draw a line like this down the middle. It's like you're doing a little proof. Okay, now I'm going to figure out what f of negative x is. Remember, take this, write it with an empty spot, cube. And what do I drop in there? Negative x. And then I figure out what it is. We did this one before. Negative x times negative x times negative x would be negative x what? Okay. And then over here, I take the normal function as it's normally written, x cubed. And then I just throw a negative in front of it. If with needed parentheses, I'd put them, but this is only one term, so I don't need the parentheses. So it's just that. Now, do you see that this side is actually equal to that side? Therefore, we have algebraically proven that these guys are odd. This is an odd function. All right. Let's try that little test with something we know isn't an odd function to show you how it wouldn't work. You don't have to do this one. Just watch me and be ready to be called on. X squared. Is it even or not? How do I test? I'm going to test if it's odd. Yes, it's even, but I'm going to test if it's odd. Negative, or f of negative x is supposed to be negative f of x. And I quick make the form like this. That's what you're going to do on the test. You have both sides. You show me, okay, on this side, I'm going to show you f of negative x. I'm going to make them a normal function with an empty spot, and then I'm going to drop that in. And you see how when it's negative x quantity squared, that'll be negative x times negative x will be positive x squared. Okay? And then over here, opposite of whatever the function was. Well, the function was x squared. Opposite, just throw a negative on front of it. You see how that's not equal to that? Therefore, I've proven it's not odd. Now, you might assume, okay, if it's not odd, it has to be even. Actually, that's not true. There is something called neither. Some things are not odd. Some functions are not even. Some functions are neither. Remember how they had to have symmetry? You know, like say we had this. It's the absolute value function. Is that odd or even? It's even. And then we had things that were like this. That had odd symmetry, because every point here could go right through the origin and be found another point over there. Okay? But what if things don't have any symmetry at all? Then they're not odd and they're not even. Okay, so what if I have a line that goes just like okay, it's a function. Could be a function. It's past the vertical line test. But it's not odd and it's not even because it doesn't have any symmetry. Okay? There are functions like that too. So we have to say there are odd functions, there are even functions, and there are neither odd nor even functions. All right, so I've given you the rule for odd. Does anybody want to take a guess at, it has to do with f of x's again. Do you want to take a guess at the even rule? There's three things we did. We did f of x, we did negative f of x, or the opposite of f of x, and we did f of negative x. Those are the three ways you can do an f of x. So to prove it was odd, we said that this one and this one were the same. Kind of. So what does opposite mean? There's really only two options. Either these two are the ones that make you the even one, or these two are the ones that make it even. All right, maybe I'm saying this in a confusing way, but this are the only three things that there are out there. And I'm going to sum it up for you. This is an example of how to find an odd function. We already did that. For an even function, it's this. It starts the same way, f of negative x. But last time, we said it had to be negative f of x. That's how you tell if it's odd. If it's even, it'll come out positive f of x. Better write that one down. It's all going to turn into alphabet soup like tonight when you go home and you've forgotten what I talked about. You need these two rules. These are like things you got to memorize, just like you have to memorize x equals negative b plus or minus square root b squared minus 4ac. Okay, so this is the kind of thing you cram the night before the test and remind yourself. What's that even rule again? What's that odd rule again? Here's the rule for even functions. Okay, so what I have to do then to prove something's even is take f of negative x and then find f of x and then figure out if this side and this side end up being the same thing, then it's an even function. All right, so let's do that. Is x squared an even function? We know it is. So f of negative x. I start with my function, empty spot squared. I keep saying that. Drop in negative x. And then when I do that, what do I get? What's that equal to? Negative x times negative x, which would be, see how the negative disappears? Okay, over here. Plain old f of x. Do I have to do anything to it? No, it's just f of x. What is f of x? X squared. It's just f of x and x squared. That's it. So now this and this, are they equal to each other? Yes, they are. So therefore, it's an even function. All right, so all of those, I went and found a bunch on the internet that were even functions. Those all have even function kind of symmetry. Do you see that? You go straight across, there's a point like this, there's a point over there like that. Okay, and if you think about it, you get how this is just f of x. And you get that this is just f of the opposite of that? Because if this x is like 2, this is like negative 2. You see how that's the even rule at work? This is just the normal function spot, and this is the opposite of the input. Like I stuck in negative 2 instead of 2. See? That's the even rule. And I think I had some pictures of odd ones back earlier. There we go, some odd ones. Those all have odd symmetry. Of course, this one, it's like, seems pretty obvious. That point going straight through the origin is that point. So that's odd symmetry. Okay, this one, if I pick this point here, over 2 and up a little, and I go through the origin, there should be a spot. Yep, there is. See, right there. And then this one really kind of freaks people out because it doesn't look like it has symmetry like you're expecting. But remember, if I pick a point like, let's say this, over 2.75 and up a little bit, just go through the origin and see if there's something just like it over here. Look at that, there is. So that one's got odd symmetry. Even way over here, this point here, if I go right through the origin, something like it down there. See what I mean? All right, so those have odd symmetry. So you can do it with a picture, or you can do it with this little formula thingy. This is the formula for odd. And this is the formula for even. And if you put them right next to each other, so just a quick 2-second, which one of these is odd, A or B? Which one's odd? B's odd, what's A? Even, all right? These two are the two functions side by side. Let's just make sure you get the difference. You get how they start exactly the same? They both start with f of negative x. The odd one ends with a negative. The even one ends with just positive f of x. So, oh, it's got 2 negatives. That's odd. However you want to remember it, that's the way I remember it. Okay. Your homework used to be that, but now we've got a worksheet for it. So let's do some of those together. this would be a little bit much to get all done tonight, so I will cut it down for you a smidge. 3, 4.